Hi, for today, for this session, we will discuss the introduction to interrupt processing. Cover concept of interrupt, register associate, an example of external interrupt, programming and handling multiple interrupt. The scenario. One sweet night, you were alone at your hostel reading a lovely book on a microcontroller. Suddenly, your handphone rang, as an incoming call is set to the highest priority. You put down your book and answered the call. After some conversation, you get back to your book. Unfortunately, you have a difficulty to retain the last page you have read. So we adjust a bit the scenario above. When you receive a call, you place a pencil at the page that you read and answer the call. After some conversation, you get back to your book and read from where you last read. This is the popular scenario used by a lot of authors in introduction of interrupt. I do love the scenario. The point there is a context saving. It's here, what it wants to show is that interrupt is actually, like the name suggests, an interrupt to what you are doing at the current moment. In your microcontroller, when you are running one type of program and you want to hold that program for a certain amount of process, we use interrupt. It means that while running a program that reads a sensor reading, you want to interrupt that program for a certain amount of instruction or to do a certain amount of things. So interrupt is introduced to the program to divert the main program to do the interrupt program. Let's look at another example of interrupt and see the basic idea of interrupt. The basic idea here is that when an interrupt occurs and are enabled in the microcontroller will place the address of the next instruction into stack. That means whenever it is doing something, the instruction that the microcontroller is doing at the current moment is placed into a stack pointer. That way, the microcontroller will memorize the present execution of an animus to your place a pencil in between the page of you read, like our earlier example. The instruction pointer is loaded with that what is called interrupt vector. It is replacing what is supposed to be your instruction for your main program. For example, the interrupt vector of an external interrupt 0 is addressed as 0 as hex 3. The interrupt service vector for all interrupts which are supported by 8051 microcontroller is listed in table 1. If you can see at our second slide, table 1. Here. It shows the interrupt numbers and the interrupt vector address as well as the description for those interrupts. Here we have interrupt 0, timer counter 0, external interrupt 1, timer counter 1, and serial port. Thus making it that we have 5 types of interrupt. External 0, external interrupt 1, timer 0 row of interrupt, timer 1 row of interrupt, and serial port interrupt. Going through the chart, this is how it works. This is the interrupt vector represented in PC. Okay. So whenever we run a microcontroller program, the program will run the address of the instruction in PC, program counter. So when we are running our program, the PC will run where the instruction is stored in our MAC address, in our RAM, from where it is shown by the PC. So when an interrupt occurs, the address of the next PC counter will be sent into stack, and the address of our interrupt will replace that address that is sent to stack into our PC counter. The next execution is going to be whatever program that is represented in the interrupt vector. So here it starts with the address, goes down, and this is the instruction of the interrupt that is stored in the program data. For interrupt to work, we must first know all the associated registers that needs to be turned on or to be set to turn on and initiate our interrupt. The first interrupt register that we will need is the interrupt enable register, IE. IE is an 8-bit register, consists of EX0, ET0, EX1, ET1, ES, ET2, and also EA. For all of the register bit in IE, the most crucial bit to be set is EA. When you want to enable interrupt, EA must be set to high, and then you just choose which interrupt you want to set. If you want to use external interrupt 0, you have to set EX0 as 1. Or if you want to use a timer 1 interrupt, you set ET1 as 1. Whatever interrupt that you are not using, you need to set those bits as 0. That is for IE register. Next, the next interrupt associated register that we need to set to enable our interrupt is called TCON register. For TCON register, it is also an 8-bit register. It is a bit addressable register. It consists of bit IT0, IE0, IT1, IE1, TR0, TF0, TR1, and TF1. You can read the function of each bit here, like what it says in the table. The main characteristic of TCON register is a control register. That means the bit that is set in TCON is used to control the behavior of our interrupt. If you look at IT0 is external interrupt 0 signal type control bit, set to 1 by program to enable the external interrupt 1 to be triggered by the falling edge of the signal, and clear to be enabled to enable a low level signal on external interrupt 0 to generate an interrupt. We will later look on the example of how IT0 and IT1 is used to enable positive trigger and negative trigger in our interrupt. IE0 and IE1 are both used for external interrupt edge flag. So both of these is used if we want to have our interrupt source from outside of our microcontroller. IE1 and IE0 is connected. If you look in the table, IE0 is connected to our pin 3.2 and IE1 is connected to our pin 3.3. So if we want to enable external interrupt or an interrupt that is triggered by an external source, IE1 and IE0 are set to high. Then we will have TF and TR register. TF and TR bit in the TCON register. TF stands for timer flag and TR stands for timer reset or timer control. Timer flag indicates if there is an overflow flag, there is an overflow in our timer register, and TR is set to set and run and reset our timer. Later, we will look at the example showing how to use both of these bit in TCON register. Next, we have IP register, stands for interrupt priority register. This is set if we are using more than one interrupt at any certain moment of our program. So if you are using two interrupts at the same time, let's say you are using external interrupt 1 and external interrupt 2, we need to set which of those both interrupt, which of them is going to be the main priority interrupt. That means either external interrupt 1 or external interrupt 0. If we set external interrupt 0 as the highest priority interrupt, so external interrupt 0 will have the priority of running first if there occur a situation where both interrupts need to run at the same time. So IP stands for interrupt priority. It is used to set the priority of interrupt if you are using more than one interrupt. Next, we have PCON register. For PCON register, it is not a bit addressable register. That means you have to declare all 8 bits to be used at the same time. It is more for the serial port register if you want to use the serial port interrupt register. We will skip this register and only show you the table. If you want to know more on the PCON register, you can read at the Ali Mazidi book at page 320. Next, so those are all of the register involving on using the interrupt. IE register, TCON register, IP register, and PCON register. IE register is bit addressable. TCON is also bit addressable. IP is also bit addressable, but PCON is not bit addressable. Next, we will look into our interrupt codes to see how the interrupt function and discuss about the actual application of interrupt. I will continue this in our part 2 of interrupt video. Thank you.